Imagine a world millions of years in the future. A world where evolution has written a new chapter in the story of life. The world is inhabited by very strange creatures, like nothing the Earth has ever seen. This is the world 100 million years in the future. The climate is very warm and very humid, all the time. Sea levels are more than 150 meters higher than today, creating vast, shallow swamps where mysterious creatures lurk in the dark water. Not only is life very different now, but the planet itself has changed. The Earth's crust is broken into huge plates like pieces of a jigsaw that jostle and slide over the face of the globe at a few centimeters a year. In 100 million years' time, the continents will be in completely different positions. But this movement is not the only reason the Earth looks so strange. Over millions of years, carbon dioxide from volcanoes has created a massive greenhouse effect, slowly warming up the planet, melting the ice caps, and causing the sea level to creep higher and higher at about 1 millimeter a year. In 100 million years' time, the sea will have flooded much of the dry land. So a combination of moving land masses and a rise in sea level means the globe has changed beyond recognition. And much of what looks like dry land on the globe is actually swamp. This swamp stretches for over 2,000 kilometers.
So at this 100 million year in the future time frame, one of the environments which we're looking at is a huge near coastal swamp. It's partially brackish or the influence of the ocean. It's got a huge amount of fresh water flowing down into it, reminiscent perhaps of some of the great coal swamps of 300 million years ago. Rich in life, teeming in a whole bunch of new adaptations. Very high moisture, high warmth, a steaming tropical jungle, magnified.
It's just the sort of place where evolution can go wild. This mighty beast is a Toraton, and this one is about the size of an elephant. It's descended from a very unexpected ancestor.
Well, the Toraton that roams the Earth in 100 million years' time has evolved from today's tortoises. And you can still see the similarities. It's got a shell, albeit a much reduced shell, and a long wrinkly neck, just of folded skin, and a head that's covered in scales. But there are big differences. It is big, this animal, and its legs have moved from a sideways position like this in the tortoise to underneath the actual animal to support it like 4 great big pillars as it walks along, just like an elephant's legs.
Any animal bigger than a ton has to support itself with legs directly under its body, not out to the side. Otherwise it wouldn't have the strength to stand up. Once the Toraton had changed its gait to accommodate this, it could get bigger and bigger. The swamp is a massive area where land meets water, and it's here that the creatures of the land meet the creatures of the water. The Toraton spends most of its time reaching up for vegetation in the treetops. But there's something down at ground level that the Toraton hasn't seen yet. A family of swampus. They look like octopuses, and they're descended from octopuses. But this warm, humid world gives these swampus the chance to spend more time on land, at the risk of being trampled by an elephant-sized tortoise. But a swampus can defend itself. The swampus has a deadly bite, a venom so powerful it's lethal even to something as big as a Toraton. The venom is a neurotoxin. It attacks the Toraton's nervous system, first paralyzing it, then suffocating it as the Toraton's lungs stop working. The swampus inherits its deadly bite from its ancestors. All octopuses today are venomous to some extent, using poison to kill their prey. Some are just venomous enough to stop their victims struggling. Others, like the blue-ringed octopus, have a venom 10,000 times more powerful than cyanide. Surely a case of overkill. In the future, such a powerful poison has also become a defensive weapon, so the swampus can meet the new challenges of life out on the land.
Along the way, it's had to adapt to a terrestrial existence and be able to actually move around and live out of the water. How does it do that? How does an octopus live out of the water? Now we know that even modern-day octopuses can do that. If you've ever seen one escaping from a marine tank, it'll climb up the corner and down the side and across the floor and back into the sea. So just by pulling themselves arm by arm along, we know that octopuses can deal with a terrestrial mode of locomotion.
Moving on land is only one problem. The octopus also has to breathe in air.
But one thing that a modern octopus can't do right now is breathe out of the water, and that's one of the major adaptations that these swamp octopuses will have had to have invented.
A specialized lining on the inside of the body cavity has a very rich blood supply, like a lung, so the swampus can breathe in the humid air, to some extent. To move on land, 4 of its arms have become runners, allowing it to haul itself across the mud with the other 4 arms. It may look strange, but there are such halfway creatures today.
A lot of animals have adapted from aquatic habitats to terrestrial ones, and we might think of that transition hundreds of millions of years ago when amphibians first crawled up on land and began their terrestrial existence. But we don't have to go that far back because we have modern examples of that now. Mud skippers, walking catfish.
Mud skippers are very strange creatures. They're fish that can leave the water, pulling themselves along by muscular fins. They can breathe out of water through their skin, and some mud skippers can survive more than 2 days on land. But for a mud skipper to survive in air, it has to keep its skin wet, so it never moves too far from water.
In all those cases, what we see is a tie to the aquatic habitat, either for breathing or for reproduction. And the same is true of our octopus. They can't get very far from the swamp. They're tied to the water that they have to go back to replenish their oxygen supply.
In the future, there's a very good reason for the swampus to venture out onto land, to raise their young. The baby swampus are kept in a nursery inside this plant, where they're fed and protected.
The youngsters of this octopus are perfectly good prey items. But by clustering them all together within what amounts to a nursery inside of this vase, the adult octopuses, which have a venomous bite, can gather around and protect the young octopi. They can bring in food to feed to them and, in a sense, keep an eye on them. You may think that we have just, in this reconstruction, invented a piece of science fiction. No, all we've done is change the players and shown you something that's going on at this very instant on this planet now. If one goes to the island of Jamaica, for example, you can observe a particular terrestrial crab that lives in the funnel-shaped leaves of a pineapple relative called a bromeliad.
The plant traps rainwater, a private pool in which the bromeliad crab raises her young. She even catches food for them. In the future, several related swampus females all work together to raise their young and defend their nursery plant. But there's another reason for raising their young in the plant. It provides the young swampus with something they need.
The plant vase, the water bowl, contains within it, as well as the octopi, a bacterium. And the bacterium is a creature which generates a toxin. As it turns out, the baby octopi are not affected by this toxin and indeed ingest it, and it becomes the basis for their venomous bite as they grow up and become adults. We've discussed what's in it for the amphibious octopus, but in a coevolutionary relationship that has to work in both directions, what's in it for the plant? The plant has timed its flowering so it occurs at the same time when the octopi are nursing their young, which means that when the flower stalk emerges from the center of this large bowl, that no herbivore is going to bother it because there are the guardian octopi around the outside guarding their young. And so the process of fertilization and pollination can take place up on the top of the flower without disturbance, without anything destroying it.
Every swampus in the neighborhood needs a nursery plant to breed in. This is an intruder, a stranger, another female looking for a nursery plant of her own. But the family won't give up their plant easily. They try to intimidate the intruder, waving their arms, flashing bright colors, showing that they're big enough and strong enough to defend their plant and themselves. The intruder gives up. There's no point in getting into a fight when she's outnumbered. Her only way out is back into the water. But there's a creature here that's found a way around the swampus venom. This is a lurkfish, and it's one of the few creatures that can kill a swampus. In the murky water, the lurkfish can't see very far, but it can sense the swampus as far as 5 meters away. It surrounds itself with a weak electric field and feels the swampus moving through the field. But electricity has a more sinister use. As the swampus gets closer, the lurkfish stuns it with a massive electric shock.
Our lurkfish in this environment is using an electrical sense to detect prey from a distance, but it's also using that same ability to stun prey and immobilize them. Now, currently, that's a very common strategy in similar freshwater fish like electric catfish.
Electric catfish use electricity to kill smaller prey. But the electric eel can pack up to 600 volts, enough to stun a human. The eel senses its prey in the water with a weak electrical discharge, and then releases a much higher voltage to shock and stun it.
Electric fish now generate voltage in small blocks, small muscle blocks along the length of the fish, each generate a small electrical potential. And like batteries in a series, those muscle blocks along the length build up a bigger and bigger charge.
The lurkfish takes this even further. It's over 4 meters long and has huge numbers of muscle blocks packed along its body, which build up a massive electrical charge. In a matter of seconds, it generates 1,000 volts. By generating such a powerful charge, the lurkfish can stun something as big and venomous as the swampus before it has a chance to fight back. With the swampus dead in the water, the lurkfish doesn't have to worry about the venomous bite. With something as deadly as a lurkfish hiding in the murky water, dry land seems much safer for a swampus. But even here, there are problems. Something is coming. Something big. A herd of Toratons. Adult Toratons. The one the swampus family killed was only a baby. These are 15 times bigger.
The adults are enormous, the biggest animals that have ever walked on the face of the planet. 120 tons. That's bigger than even the biggest dinosaur. Now, there are lots of advantages about being so big.
They're far too big for swampuses to kill. Adult Toratons have no predators. But they're also big because they eat vegetation. And not only so they can reach high up into the treetops.
When you're eating all this vegetation, you need to ferment it to get all the goodness out of it. You need an enormous stomach, a big barrel-shaped stomach, and the bigger the animal is, the bigger its stomach's going to be, so it can extract all the goodness out of all the vegetation over several days.
So size really does matter. Animals this big can just move from tree to tree, stripping off the leaves. But size also creates problems.
Of course, there is one major problem about being so huge, and that's when it comes to mating. Now, modern-day tortoises mate on top of each other, but of course the Toraton is far too big for that. The female will not be able to support 120 tons on her back during mating. They've solved this problem by mating back to back. They're simply backing to each other and the face away from each other during courtship and mating. During the actual mating, when they are back to back, the male and the female raise their tail to reveal the cloaca, and the two cloacas actually touch, and that's when the sperm is transferred from one to the other. That's the only physical contact they have during mating.
It takes a long time for a Toraton to grow to full size, and they live in family groups, protecting their young for 30 years. But one of their babies is missing, and the herd is restless. They don't know their youngster has been killed by a swampus, so they're not out for revenge. But their search does take them into an area where the swampus are raising their young and where the baby died. For the Toratons, the nursery plant is just another bit of vegetation in the way. One careless kick, and the plant is destroyed. But where are the young swampus? They're old enough now to have been taken to safety, a branch over the swamp, out of reach of the Toraton's big feet and the lurkfish. But before they can drop into the water, their mother has to distract the lurkfish, deliberately drawing it away from the babies, staying out of range of its deadly electric shocks. Once far enough from shore, the agile swampus hides herself in the vegetation, keeps still, and so loses the lurkfish. She's bought the babies enough time to find a safe hiding place in the water. A vast swamp where the land meets the water. A rich, fertile place in a constant, warm, wet climate. With such benign conditions, evolution has run riot. New animals have moved onto land and formed a partnership with a plant. A giant fish hunts and kills by electricity. And towering above it all, the biggest creatures ever to walk the earth.